Next property, fifth, states as if two parallel lines, that is, two rows or two columns, have identical elements, the value of the determinant is 0. To explain this, let D equal to A1, B1, C1, A2, B2, C2, A2, B2, C2. Here R2 and R3 have identical elements. The value becomes A1 times B2, C2 minus B2, C2 minus B1 times A2, C2 minus A2, C2 plus C1 times A2, B2 minus A2, B2, which is equal to 0. Let D1 equal to A1, A2, A3 as the first column, B1, B2, B3 as the second column, A1, A2, A3 as the third column. Here C1 and C3 have identical elements. Expanding this, we get A1 times B2, A3 minus A3, B2 minus B1 times A2, A3 minus A2, A3 plus A1 times A2, B3 minus A2, B3, which comes out to be equal to minus A1 times, pulling minus common here, we get minus A1 times A2, B3 minus A3, B2 plus A1 times A2, B3 minus A2, B3, which is equal to 0, which shows the result. The next property, number 6, is if the elements of a line, row or column, are multiplied by a constant k, then the whole determinant gets multiplied by that constant. The explanation for this is, let D equal to A1, B1, C1 the first row, A2, B2, C2 the second row, A3, B3, C3 the third row, equal to A1 times B2, C3 minus B3, C2 minus B1 times A2, C3 minus A3, C2 plus C1 times A2, B3 minus A3, B2. Let D1 equal to A1, B1, C1, KA2, KB2, KC2, the elements in the second row, and A3, B3, C3. Now here, the elements of row 2 have been all multiplied by k. Therefore, D1 equal to A1 times k times B2, C3 minus k times B3, C2 minus B1 times k A2, C3 minus k times A3, C2 plus C1 times k A2, B3 minus k B2, A3. Pulling out k common, we get it is equal to k times D, which shows that we D1 equal to k times D. A corollary immediately comes. We have proved that D1 is equal to k times D. Putting the values of D1 and D, we get A1, B1, C1, KA2, KB2, KC2, A3, B3, C3 is equal to k times A1, B1, C1, A2, B2, C2 and A3, B3, C3.